Alright, what's up, folks? This is a pre-recorded lesson. In case you might have missed today's new lesson or need a quick refresher on lesson 2-3 subatomic particles. So practically, we're going to look at the components of an atom and how we can create one using a model called a Bohr model. So, what do you think it looks like with all of its components, an atom? Right? You have these negatively charged particles called electrons, positively charged particles called protons, and zero charge or neutral charge particles called neutrons. Okay, the protons and neutrons are super heavy, and what they do is that they make up the center of an atom in which we call a nucleus. All right. The electrons, on the other hand, are super light. They fly around kind of all over the place around the nucleus, and they kind of move around on these orbits called shells. Okay, we're going to call them electron shells. So we use E minus to talk about an electron. Okay, so this is the basic shape of an atom, and this is called a Bohr model, right? So let's look at what else we got. So how do we determine the number of protons, neutrons, and electrons in an atom? So this is a typical representation of an atom when we're just writing it on paper. You first write the symbol right here, and then you write the atomic mass, which tells you the number of protons and neutrons in an atom. So that's what my atomic mass tells me. And then the atomic number, on the other hand, tells me the number of only protons. Okay, so atomic number. So this representation is called just a simple chemical notation. Right? We just write it on paper. But what happens if we see it on the periodic table? It's going to look a little different, okay? You still have the element symbol here, but now you have the atomic number on the top, all right? And then the atomic mass, on the other hand, is going to be on the bottom, right? Compared to atomic mass on top and atomic number on bottom when you have chemical notation, all right? So just remember, when you read the periodic table, you have to switch the atomic number and atomic mass. All right, so now what does that tell me? I can find the number of protons by looking at that, the atomic number. Okay, and every element has a unique atomic number. So this is what distinguishes elements from each other. Okay, so if you look at the periodic table, so let me show you that real quick. On here, on your Google Classroom assignment, click on the periodic table right there that is attached. And if you look closely, you can see all of the numbers. Right? Every element right here has a unique atomic number. All right, so hydrogen has one, or so atomic number is one, or one proton. Helium has two. Right, lithium is 3, beryllium is 4, boron is 5, carbon is 6, right? It's all increasing by 1 as you go from left to right. So if you change the atomic number or the number of protons of an element, you completely change an element. Right? So atomic number tells you the number of protons. All right, so how do we find the number of neutrons? You look at the atomic mass minus the atomic number, and then you will round up the mass right here to the nearest whole number, because if you look over here, right, 12.011, that's kind of like an average atomic mass. And if we want to find the number of neutrons, which is, the number of neutrons, you have to subtract the atomic mass minus the atomic number. So for this instance, atomic mass, I'll round it up to 12, and then I'll subtract it from the atomic number right here, which gives me 6. Right? So I would say this carbon atom has 6 neutrons. Okay, so why does this math work? Let's look closely at the mathematical properties. Right? So we know atomic mass is protons and neutrons combined, because the mass of atoms is based on its heaviest particles, which is the protons and the neutrons. The electrons are super light. They don't really count as part of the atom's mass. Okay? But then you subtract it from the atomic number, which is the number of protons, and what you're left with is just the number of neutrons, right, when these cancel out. So that's why you use this to find the number of neutrons. You use the atomic mass minus the atomic number. All right, and for this one, click. All right, number of electrons is the same as the atomic number. All right, so that's only for neutral atoms, since the positive protons from the atomic number cancel out the negative electrons. All right, we're going to see later on that there can be different number of electrons based on an ionic charge when you have extra electrons or less electrons. But we'll talk about that next lesson. All right, just for now, know that neutral atoms have the same number of electrons as protons. Okay, so you look at the atomic number for that. All right, so let's revisit the Bohr model of an atom. We know that the nucleus is made up of the proton and neutrons, and that the outside right here, let me write this as shells. So, okay, so the shells, the rings that surround the nucleus, tell us where the electrons kind of fly around. All right, so you want to wonder, what element is this? Okay, so the main thing to remember is that the atomic number, like I said before, you need to look at the atomic number, which distinguishes an element, right? Because every element has a unique atomic number. How do you know the atomic number, and what does that tell me? You look at the number of protons. So that's the positive particles right here. So if I see that there's 6 protons, I look at my periodic table. So let me go back here. Okay, go back to that right here. And I look at the atomic number that has 6. And oh, it's right there. So I have, use the pencil, right? I see that atomic number right here is 6. So that means that atom that in the Bohr model is carbon that we see right there. Okay, so let's go back here. So this is a carbon atom. Yay, carbon. All right. What's its atomic number and atomic mass? All right. Once again, the atomic number. Let me go back to presentation. So the atomic number right like that. Okay, is equal to just the number of protons. So I'll say it's 6, like we looked on our periodic table. And the atomic mass, okay, is the sum of the heaviest particles in an atom. So that is the protons plus neutrons, which gives me, okay, 12. Right? This is going to be my mass, like that. Okay, and then because it's really small, we use something called atomic mass units, like 12 AMU, to describe the mass of an atom. Okay, so that's how you do that. And we're going to now specify the number of protons, neutrons, and electrons for each element right here, based on its chemical notation. So, as we said before, we know that the number of protons is 6 here. Okay, if the atomic number is 6, right? The number of protons is 6. It's the same for neutrons. And then I look at the mass number, right? Number of neutrons, like we did, is 12 minus 6 equals 6. Is the number of neutrons. Excuse me. All right. So, okay. So remember, when we solve these, the top number in chemical notation is the atomic mass, which is the number of protons plus neutrons, right? And the bottom number is only the atomic number, which is only the number of protons. All right, so let me solve one more when you do this with chlorine. So a number of protons, you look at the atomic number, so that's 17. Chlorine has 17 protons. Okay, since it's a neutral atom, there's no plus or minus next to the symbol. It's going to be the same number of electrons, 17. Now, how do I find the number of neutrons? You look at the atomic mass, 35, and you subtract it from the atomic number, 17. It's going to give you 18. Right, so you have 18 neutrons right there. All right, and if you keep on going, try the last one on your own. Okay, pause this video, and if you already went forward, right, this is kind of what you should get for your table. All right. So your quiz is going to ask you something like this, where you have to find the number of protons, neutrons, and electrons for each element.